Good morning, and welcome to Confidential Computing with AWS Compute. I'd like to first begin by thanking all of you for waking up bright and early and choosing to spend your time with us. You have a lot of choices, but you chose us, so we hope we make this worthwhile for you. I'm Arvind. I'm the specialist responsible for confidential compute at AWS. I will be presenting this session alongside JD Bean, Principal Security Architect, EC2. Here's the agenda for today. We will start by introducing confidential compute on AWS. We'll then introduce the AWS Nitro system, AWS Nitro Enclaves, and Nitro TPM. We will then deep dive into Nitro Enclaves. We'll talk about how it's operationalized. We'll talk a little bit about what's new with Nitro Enclaves, and then close that out with some of the key features and benefits of Enclaves. We'll then piece it all together by walking through a sample data flow and show you how to bring data from an S3 bucket or a data lake of your choice into an enclave and process it. We'll then talk about some of the example use cases, market segmentation, where we think there's a lot of traction for confidential computing. And then we'll touch a little bit on Nitro TPM and Secure Boot, and we'll close it out with some resources for you. All right, so what is confidential computing? Before I get into that, can I get a sense of how many of you are familiar with confidential computing? Just a quick show of hands. Okay, that's what I thought, about 10 to 20% know about it. The rest are curious to find out what it is. So what is confidential computing? Let's first look at what a standard EC2 instance, if you will, looks like. There's the instance on one side. There's the cloud operator who's powering and helping enable and operationalize the instance. All of the different components of your code are sitting on the same instance, whether it's trusted component of the code, untrusted component of the code, code that's processing highly sensitive data, code that's processing regular data. Everything is sitting on the instance. Confidential computing at AWS is defined as the use of specialized hardware and associated firmware to protect data while it is being processed from any unauthorized access. The emphasis here is on data while it is being processed. The mechanisms to protect data while it's at rest and in transit are pretty well documented, mature, and have been used for a while. Confidential computing is about extending that support, that security for data while it's being processed from any unauthorized access. But when I say any unauthorized access, what does that really mean? There are two distinct security and privacy dimensions that customers are most concerned about when we talk about confidential computing. Dimension one is where customers want to protect their code and data from operators on the cloud provider side, which is AWS in this case. So you have your code and data running on your instance. You want to protect it from the operators on the cloud provider side. The good news is with our Nitro system, with all of our Nitro-based instances, you get that protection by default. Dimension two of confidential computing is where customers want to protect their highly sensitive data and code from themselves, from even admin-level users on their side, or from malicious actors who could pose as admin-level users and gain access to the data. So to recap, two dimensions. Dimension one is where you want to protect your code and data from us, and dimension two is where you want to protect that code and data from yourselves. But why does this matter now? Why are we talking about confidential computing? Why are you seeing this topic gain more traction? Here's a smattering of some of the data types that are being classified as highly sensitive data and are getting processed in the cloud. Personally identifiable information, encryption keys, healthcare data, financial data, digital assets, IPs, sensitive machine learning models. All of this are being processed in the cloud. This is not new. They've been in the cloud for a while. Customers have been processing this data with sensitive workloads for a while now. But now, everybody is starting to get more sensitive about extending the level of security, expanding the security posture of their workloads. Beyond protecting data at rest and in transit, now we are seeing a lot more need and demand to protect data while it's in use. That's why we're talking about confidential computing more and more. That's why you're seeing this gain more traction. But how do we bring this to you? The key capabilities that we have today to bring confidential computing capabilities to you, number one, begins with our AWS Nitro system. AWS Nitro system is the foundation of all virtualization for our modern EC2 instances. That's pretty much all of the instances that we have launched since early 2018. AWS Nitro system addresses dimension 1 of confidential compute that I talked about earlier, where you get to protect your code and data from us by default. No AWS operator can touch any of your code and data. That's just how it's architected. JD will talk about it a lot more later in this session. The next capability is AWS Nitro Enclaves. AWS Nitro Enclaves provides a hardened and highly isolated compute environment, which provides additional isolation beyond what the Nitro system provides to protect your code and data. And that will address dimension 2 of confidential compute I talked about earlier. And lastly, we also recently launched Nitro TPM, which allows for cryptographic attestation of the health and integrity of your instances. I'm now going to turn it over to JD to talk to you about the AWS Nitro system.
Thanks, Arvind. Hi, all. Good morning. So, the AWS Nitro system. Right? The topics that we're covering today in confidential computing, like we talked about, it's about raising the bar, right? It's about extending the traditional concepts we have of protecting data while it is in transit and at rest, and really raising the bar to begin thinking about how we can leverage special purpose hardware and firmware and associated software to protect data while it is in use. This is the future. In order to discuss the future, we're going to take a brief trip back to the past. So, on the left side of this screen, you see a representation of classical virtualization, if you will, traditional virtualization. And this is the image that I think that many of us would draw on the back of a napkin if someone asked us to sort of sketch out what a virtualization system looks like. Certainly is what I would sketch out. What you have there is a system host, a main board, a server, and on that server at its fundamental base level is a hypervisor or a virtual machine manager. Right? This is the fundamental piece of software that is responsible for virtualization, for carving up a single physical server into virtualized subsystems, right? Multiple operating systems that can run on the same hardware at the same time. But a virtualization system is much more than just the hypervisor or virtual machine manager, right? Customers expect a lot more out of that system and service, right? So you're going to have a number of additional services running on this board, the system. You're going to have management and orchestration, observability, security features. All of that is going to run as well. In addition, a virtual machine generally is going to want to perform some form of I/O, or input-output, right? The virtual machine is going to want to have access to storage devices or network devices to communicate, to receive data, to record data, et cetera. And all of those functions generally also require additional pieces of software, things to interface with external devices and then emulate a virtual representation of that device to present to a virtual machine. In most virtualization systems, like the Zen system, for example, you're going to use a general purpose operating system called DOM0 to contain all of these features as well. So you've got a lot of additional software running on this on this virtualized system before we even get to the really important part, which is the virtual machines. In AWS parlance, the EC2 instances. So these white boxes at the top of our host here, these are the virtual machines. And there's a lot to be said about this model, right? This can be a very, very strong isolation model. So in EC2, traditionally, right, we've had extremely strong isolation between tenants on our system. We don't do things like share contemporaneous core resources across tenants. Tenants are leveraging the hardware-based isolation of the CPUs in these systems to maintain isolation between tenants and between the virtualization system. That said, at AWS, we're always looking to innovate and move forward in order to deliver better value, services, and features to our customers. So we looked at this traditional model of virtualization almost 10 years ago, and we looked and asked ourselves, how can we raise the bar? How can we push this forward to deliver better performance and, critically, better security for our customers? And we set out on a journey that culminated in the release and announcement of the AWS Nitro system, which you see on the right side of the screen. The Nitro system is a reimagining, a reinvention of what cloud-native virtualization can look like. Now, I understand it's a relatively simple drawing, but the system itself is, well, quite beautiful. So what we've done is removed the networking, the storage, the management, the security, and monitoring from the general purpose operating system, from the DOM0 that ran on the main system board of the host. We've removed DOM0 entirely, and we've moved those functions into special purpose, dedicated, custom-built pieces of hardware. Hardware accelerators that are built by Annapurna Labs, our internal silicon development wing. Many of you may have heard on Monday night, Peter DeSantis announced the 5th version of the Nitro chip that powers these features. We've moved these off of the system mainboard, creating 2 independent, logical, and physically isolated security domains within the Nitro system. The vast majority of our virtualization system, the AWS code needed to provide the EC2 system, no longer runs on the same physical mainboard as customer workloads. This allows us to dedicate the full performance of the system mainboard. That's your Intel, AMD, even Graviton server chip to customers, and to adopt sort of a microservices-like architecture using physical hardware and firmware that we have built and designed specifically for this purpose. The only thing that's left running on the system mainboard is a highly intentionally minimized and custom-developed hypervisor that exists to perform the bare minimum features necessary to allocate resources, hand them over to a virtual machine, and then, frankly speaking, step out of the way. So let's take a look at the components of this Nitro system. You heard me already speak a bit about the Nitro cards. These are the individual computers, the systems on a chip, that work together as a network, providing that second domain of the Nitro system, the bottom half of the last slide. Each Nitro card is dedicated to performing specific functions, accelerating those functions for better performance, better security, and better isolation from customer workloads. We have Nitro cards providing local instance storage using NVMe. We have elastic block storage, which is a network-based block storage for EC2 instances. We also have a card that is responsible for providing the network accessibility to EC2 instances. We also, of course, have a very special Nitro card, the queen of the Nitro cards, which is the Nitro controller, responsible for orchestrating and providing the management, monitoring, and security features of the Nitro system as a whole. The second component is the Nitro security chip. This is the physical special purpose piece of hardware that is integrated into our system mainboards and provides two critical functions. One is that it is able to prohibit any software running on the main system board from writing to non-volatile storage. Right? That means things like flashing firmware on one of our instances isn't possible unless it's been validated and approved. Secondly, and very, very critically, the Nitro security chip plays a very important role at system boot up time. The security chip is able to allow the Nitro controller to extend its root of trust into the system mainboard, validating all of the components, all of the non-volatile storage, all of the firmware on the system at initialization time to ensure that each component is approved and unmodified in state before the system is allowed to ever handle a customer workload. Lastly is the Nitro hypervisor. I mentioned the hypervisor a bit earlier. This is a very, very lightweight hypervisor. We have intentionally removed all of the features that do not need to be there. There is no file system. There is no shell. Right? There is nothing that does not need to be there. And this hypervisor allows us to provide nearly indistinguishable performance from a bare metal system. The main task of this hypervisor is simply allocating memory and CPU, providing them to instances, and stepping out of the way. Critically, each of these critical components in the Nitro system, all the security relevant components, can be live updated with nearly imperceptible performance impact. This allows us to never have to ask the question about whether or not a patch is important enough to interrupt a customer workload. That trade-off doesn't have to be made. We're able to update these components and ensure that they are running the most secure and up-to-date software without ever impacting a running customer workload. Very, very important, and Arvind mentioned this earlier, in the context of confidential computing, is what this model has allowed us to do. So as I mentioned earlier, there are two security domains in the Nitro system. We have the system mainboard, the server, where customer workloads run, and we have the Nitro card domain, where the virtualization system functions run. On the server, with the hypervisor, there is no interactive access capability whatsoever. The server communicates exclusively with the outside world of the EC2 control plane through the Nitro cards. Right? There's no SSH server, there's no network connection, there's no file system. There is no way for an operator to directly access this environment. Similarly, that pattern is repeated with the next domain. The Nitro cards, which are connected to the EC2 control plane, also do not have interactive access mechanisms. There's no SSH, there's no hopping up and pulling up a shell and interactively accessing. The only way for an AWS operator to interact with the Nitro cards is through well-defined, least privilege, audited, authorized APIs. And none of those APIs provide a mechanism to return to an operator the contents of customer instance memory, encrypted EBS volumes, or other customer data. I do want to underscore that point. This system is designed as a hermetically sealed system. There is no data disclosing interface. There is no interactive access. This is an engineering challenge, right? I think anyone who has worked with software in production knows what it is like to want to pop into that production system and debug and understand what's going on when something doesn't go according to plan. That function does not exist in the EC2 Nitro system. Occasionally, very, very rare circumstances, that does make it difficult to debug problems. It puts a strong emphasis on EC2 engineering teams to ensure that they test and carefully manage their change management process before ever hitting production. However, we feel strongly that the trade-off between the occasional friction of debugging and the security and confidentiality guarantees that this design provides are well worth it. We prioritize customer confidentiality and security over everything else. So we don't have time, perhaps, to go as deep into this topic as some might like. I'm very pleased, however, to be able to introduce and share with you today that a few days ago we published a deep dive white paper describing in depth the AWS Nitro system and its security design. We cover the three components that I discussed today, the Nitro cards, the Nitro security chip, and the Nitro hypervisor, and provide deep dive explorations of topics such as integrity protection, tenant isolation, micro-architectural side channel mitigations, and critically, our no operator access design. If you're interested to learn more, I encourage you to check it out. And ultimately, what I want to leave you with is the understanding that when it comes to that first dimension of confidential computing, right, isolation and protection of data while it is in use from the cloud operator, the Nitro system is the star technological protection for dimension 1 of confidential computing. To talk a bit more about how we think about dimension 2 of confidential computing, I want to invite Arvind back up to talk about Nitro Enclaves.
Thank you, JD. Okay, so we heard about the Nitro system, about how it addresses dimension 1 of confidential computing that I had defined earlier. Let's switch gears and talk a little bit about how we address dimension 2, the foundation of which is still the Nitro system that you heard about. But to address dimension 2, we have a different EC2 feature called Nitro Enclaves. What is AWS Nitro Enclaves? What does it give you? To understand that, let's first take a look at what a standard EC2 instance would look like. Here's a high-level representation of what an instance might look like. Within your instance, you could have your OS, your applications that are running in there to process the data, third-party libraries probably, and of course, a bunch of users who could have different levels of access to what's in the instance. But most importantly, when you want to process data, you are going to bring encrypted data into the instance and eventually have to decrypt it and reveal plain text data to process it. When you reveal plain text data to the instance, now all of the other entities we talked about earlier could potentially have access to that plain text data. And that's really where dimension 2 comes into play, because now you could potentially have users at your end who have access to the data. Your own software has access to that data. So how do we protect it? How do we make sure we have that additional protection bolted on to make sure we're protecting this highly sensitive data and code from yourselves? That's where Nitro Enclaves comes in. Nitro Enclaves provides the additional isolation for data while it is in use. All you have to do from your standard EC2 instance today is carve out CPU and memory resources and create that enclave. So if you're running an instance today, you could dedicate a portion of that instance conceptually by dedicating X number of CPUs and memory that your application is going to require to run inside the enclave. The enclave is connected to the parent instance from which you carved it out through a secure local channel. It's a highly isolated and constrained virtual machine, which means there is no external network connectivity from an enclave. There's also no persistent storage. There's no interactive access, so there's no root user access. You can't SSH into that enclave and see what's going on. So now that you created the enclave, you could safely drop your application in there and bring encrypted data and decrypt it within the enclave to securely process it. At this point, the whole enclave behaves like a black box to you. You cannot see what's going on inside. It'll process the data, and if you choose to, you can re-encrypt the data and send it out. What you do with the data inside the enclave is part of the shared responsibility model on your side, where our recommendation is for you to bring encrypted data through the parent instance, decrypt it inside the enclave, and then re-encrypt the data and send it back out. At no point we want the parent instance to be able to see plain text data. The enclave is the only one that's ever going to see it. That's the model we recommend as you deploy enclaves for sensitive data processing. So to recap, with Nitro Enclaves, you're getting additional isolation on top of what you already got from the Nitro system to protect data while it's in use. What is it and what is it not? The enclave is an isolated, hardened, and constrained virtual machine. It has its own lightweight Linux OS. It has an independent kernel, and the enclave has its own encryption keys. It'll create its own key pair, be able to distribute the public key, and the enclave is the only one that ever keeps its private key. So if you wrap data with the enclave's public key and send it to the enclave, only that enclave, not a enclave, only that enclave will be able to decrypt that public key. The enclave looks a lot and behaves like a container, but it's not a container. We're using the Docker format to build the enclave image file to spin up an enclave, but that's about it. The enclave has no persistent storage, as I mentioned earlier, and it has no external network connectivity. The only connection that you have from the enclave is a secure local channel to the parent instance. So the parent instance acts like a conduit between the enclave and everything that's external to the instance. The enclave also has the ability to prove its identity. After you spin up the enclave, the Nitro hypervisor will sign an attestation document which contains measurements about the enclave that just got spun up. It has hashes of the enclave image, the application that's running inside the enclave, the parent instance ID, and some other information that all gets packaged in that attestation document. So the enclave, when asked, can produce that attestation document to prove its identity and use that to get secrets from external services from which it's going to be able to process this sensitive data that's just been dropped into the enclave. The enclaves also allow user-defined info like nonce if you want to avoid replay attacks. Those can also be added to the attestation document and produced for purposes of attestation. We leveraged all of this we just talked about to provide you with first-class integration with AWS KMS. The enclave can prove its identity to KMS with the attestation document we just talked about, the one that got signed by the Nitro hypervisor. And KMS will validate this against a preset key policy. Only if the document matches, the measurements in the document matches the preset key policy, will the KMS decide to reveal secrets to the enclave. The enclave can then proceed to get the secrets, decrypt, use that to decrypt the data that's sitting inside the enclave. So all along, you heard us talk about the capabilities that we've had in place, the Nitro system, Nitro Enclaves, we launched it about 2 years ago. But what's new? What have we been doing to innovate? What have we been doing to expand the portfolio of confidential compute? Number one, very recently, we announced support for Nitro Enclaves for Graviton. Nitro Enclaves is now supported on AWS Graviton 2 and Graviton 3 CPU-based instances. This allows you to leverage the price-performance benefits that come from adopting Graviton-based instances, along with the sustainability benefits due to the lower power consumption of Graviton CPUs. With this support, you also now get to use a choice of smaller instance types, a total of 2 vCPUs. What does that really mean? Let's unpack that a little bit. If you're using an x86-based instance, then one core is actually 2 vCPUs because of hyperthreading. But we don't have that concept at all with Graviton. So one core is actually 1 CPU. So if you have applications that are not too compute intensive, like ACM for Nitro Enclaves, then you could actually get away with just dedicating 1 vCPU instead of 2 for an enclave. So this lets you choose smaller instance types for certain types of applications. Again, leveraging the cost benefits of using Graviton-based instances. And lastly, with this introduction, with the support, we now have Nitro Enclave supported on Intel, AMD, and Graviton CPU-based instances. On the screen, you're just seeing a smattering of some of the Graviton-based instances that we've rolled support out for Nitro Enclaves. And then, as recently as yesterday, we now have support for Nitro Enclaves with AWS EKS. What does that mean to you, right? Let's take a step back and think about how the life cycle of a Nitro Enclave is managed. Today, to manage the life cycle of Nitro Enclave, you use a command line tool called the Nitro CLI. Some customers who are already familiar with using Kubernetes for their deployments want to use tools that they're familiar with to orchestrate enclaves along with their Kubernetes deployments. If they have to do it prior to yesterday, they'll have to write their own code so Kubernetes can orchestrate Nitro Enclaves. But with this announcement, with this launch, we have now made it easy for you. We now support Nitro Enclaves with Amazon EKS and any managed Kubernetes for orchestrating Nitro Enclaves. You can now use familiar Kubernetes tools to orchestrate, deploy, and scale Nitro Enclaves from Kubernetes pods. As part of this launch, we've also provided an open source tool called Nitro Enclaves Kubernetes Device Plugin. This device plugin allows the Kubernetes pods to be aware of the enclaves and gives them the ability to manage the life cycle of these enclaves. We have a lot more information and technical details about this on our documentation page and also on GitHub. I encourage you to go and take a look at this. We're also happy to talk about it after this session with you if you're interested in learning more about Amazon EKS and self-managed Kubernetes support with Nitro Enclaves. So let me recap a little bit about what we just talked about enclaves. Here are the key features and benefits. I would just bucket it under three big topics. Number one is the additional isolation and security you get with Nitro Enclaves. Number two is the flexibility, and number three is cryptographic attestation capability. The additional isolation, I think we've talked enough about it. The isolation you get with the Nitro system, and then the additional isolation you get with Nitro Enclaves by creating this hardened and constrained virtual machine which has no storage, no network connectivity, and thereby ensuring that you have a system that doesn't even allow you access to your own data. The flexibility is what we just talked about with the what's new. It's processor agnostic. It doesn't matter what processor-based instance you have on your fleet. It could be Intel, it could be AMD, it could be Graviton CPUs. We support Nitro Enclaves on all of them. And also, when you carve out the CPU and memory resources for your application, you have a wide range of flexibility. You can choose the combination you want to use depending on the application and the payload and the data payload that you're going to drop inside the enclave. So it's an extremely flexible solution. And lastly, cryptographic attestation. Enclaves can prove their identity and authorize the code that's running in the enclave to make sure that is the piece of code that should be processing the data that you're looking to process inside the enclave. The enclave creates its own key pair and also comes with first-class integration with AWS KMS. We have talked about all of the key concepts, how it's built, and what it's used for. So let's look at what a sample data flow looks like, right? But to understand what a sample data flow looks like, let's first understand who the key stakeholders here are. For simplicity, let's look at 3 big stakeholders. Number 1 is the data owner. This is the person who has all of the sensitive data, probably the most to lose if the data was to be compromised. Number 2 is a system administrator who manages the lifecycle of the instances and who has access, potentially, to what's running in the instance. And number 3 is the developer, the one who develops the application that's going to process the data, who could potentially have some malicious code running in there. As you can see from the way I'm describing this, this is a scenario where nobody trusts anybody, right? And nobody needs to. And that's the whole point of developing systems like this. So to use enclaves, what do you have to do? How do you put it through the data flow? It's a very simple 3-step process if you abstract away everything and take a look at it. Step 1 is where you fetch encrypted data and bring it inside the enclave. Step 2 is what we call send and verify, where the enclave is going to send that attestation document that we talked about earlier to an external service like AWS KMS, which is going to verify the attestation document and decide if it's going to reveal secrets to the enclave or not. And step 3 is where the enclave receives the secrets, so it can then go ahead and proceed to process that data. Are we good? Yeah. I'll now turn it over to JD to continue with the data flow.
Great. So we have our parties. We have a problem. Let's go ahead and see how this plays out. So a few concepts here to lay out. We're using Amazon S3 as an example here. This is an object storage layer, but really, there's nothing special about S3. We're really just thinking about a persistent store for our sensitive data in encrypted form. The other concept that I want to highlight is that of envelope encryption. Envelope encryption is a very common pattern in which data, a larger amount of data, is encrypted using a data key. That data key is itself encrypted under a key that lives in a key management system. In our case, AWS KMS, which uses FIPS-validated HSMs to manage keys. So our data is envelope encrypted, stored in Amazon S3, and is fetched by our parent instance, brought into the instance, and an enclave is deployed. The parent instance cannot access the data because it is encrypted at rest using keys that it cannot access. However, if that encrypted data is sent over the secure local channel, the VSOC, to the enclave application, the enclave application can decrypt it. And it decrypts it as follows. The enclave requests from the Nitro hypervisor a signed attestation document. The attestation document includes the specific measurements that are unique to this enclave. And particularly important, one of those measurements, we'll call them a PCR value, is PCR0. PCR0 represents the bit-for-bit exact code that is used to boot this enclave. This is the exact application cryptographically measured and signed. Additionally, it includes a public key, which corresponds to a private key that has been generated by this enclave when it starts up. The enclave can then make a request to KMS, send the encrypted key along with the attestation document, encrypted in transit, proxied through the parent instance up to AWS KMS. Now, KMS, as Arvind mentioned, has a first-class, very, very convenient integration with Nitro Enclaves attestation documents. KMS knows how to extract that document from the request, how to parse it, unpack it, how to validate its signature, how to pull out the PCR0 value, and to check that value against the policy for the KMS key, which allows decryption only from this specific application running in a Nitro enclave. So once KMS completes all of those steps, validates the document, confirms that this enclave is permitted to decrypt this key, it will decrypt the key and re-encrypt it using the public key provided by the attestation document. So this key has now been re-encrypted at the payload level and sent, encrypted in transit, back through the parent and in to the Nitro Enclave. The Nitro Enclave now has direct access to this data and can process it to derive business value, to answer critical questions, or to perform sensitive operations. Now, before we move into the question of, okay, well, what are the use cases? What do we do with this data now that we've securely decrypted it and brought it into this isolated Nitro Enclave environment? I want to highlight one thing, which is you may have noticed there's some similarities in the model of a parent EC2 instance and a Nitro Enclave, and the model of the two domains of the Nitro system. We base all of what we do, or at least 95% of what we do, on customer feedback. Customers really, really responded and really, really liked the Nitro system model. But the question that they posed to us was, how can we build systems like you've built the Nitro, like you have built the Nitro system? How can we build our own hermetic systems where we can actually work with sensitive data and can comfortably say that there is no mechanism for our operators to access it? That is what Nitro Enclaves enables customers to build for themselves in their own workloads. So, on to that question. What do we do with this sensitive data? What type of data processing? Well, as you've seen, decryption of data is often the first step, getting your sensitive data securely into your isolated environment. Common activities that customers want to do with Nitro Enclaves, because Nitro Enclaves is a very flexible and general purpose computing environment, it enables customers to do any number of sensitive data processing activities, such as signing using a sensitive cryptographic credential, but ensuring that that signing process meets and matches prescribed policies. Tokenization and masking of sensitive data, and even inferencing of machine learning models are common sensitive data processing activities. We see customers from across different industries seeking to solve different business problems leveraging Nitro Enclaves. We have customers working in the blockchain space, sensitive data processing analytics, advertising technology, and even central bank digital currencies. Another critical integration and use case for Nitro Enclaves is actually one that is provided by AWS. So we have ACM for Nitro Enclaves, which is an integration with Amazon Certificate Manager that allows customers to use publicly trusted and managed certificates vended by Amazon Certificate Manager on their own EC2 instance without ever having access to those private keys for their certificates. This allows you to terminate TLS with a managed certificate directly on your EC2 instance using the Nginx or Apache web servers. As I also mentioned, there's also the protection of sensitive IP. So we've talked a lot about sensitive data, but there's also the concept of sensitive code, where the thing that you are trying to protect is the application itself. So machine learning models are a great example of that, where customers will invest substantial amounts of effort into training a valuable machine learning model and wants to be able to deploy that model for inferencing and collaborating with others without concern about inadvertent or unauthorized access to that model itself. So customers can actually deploy that model inside a Nitro Enclave, provide it with inputs, and simply receive back the inferenced outputs. I'm going to have Arvind to come back and talk about a few more emerging use cases and workloads that we're seeing.
Thank you, JD. So that machine learning model use case is a good segue for some of the other use cases that we'll talk about, right? Because if you really think about it, there could be one entity that owns the model, a different entity that owns the data. And maybe somebody wants to license it. I want to make some money out of licensing that model, but I don't want you to look at it. Enclaves provides the perfect environment to go do that. Drop your model inside the Enclave, drop the data in there. Nobody gets to see what the model looks like. Nobody else gets to see what the data looks like. But both benefit out of using an environment like that. That's the real value, where you're starting to bring multiple parties who don't trust each other, but who could benefit from each other, work together. Some of the other areas we are starting to see a lot more conversation and traction with something like Nitro Enclaves are blockchain workloads. Number one, blockchain bridging. What does blockchain bridging mean? If you have multiple different public chains and you're trying to move assets from one chain into another, maybe you want to move something from Bitcoin into Ethereum or something else, two different chains. When you move it between chains, it eventually has to hop the chain. It's got to hop somewhere. It actually hops on a node. Now, those nodes need to be secure. Those nodes need to make sure that nobody has access to this sensitive data that's coming in. Maybe it's ownership data. Maybe it's the asset itself that's coming into the node and moving on to the next one. That's what blockchain bridging is, if you've not heard the concept before. And Enclaves provide a great trusted execution environment for these nodes where blockchain bridging can happen between two different chains. It can happen between two public chains. It can happen between a public chain and a private chain, whatnot. Another big use case is hot wallets for digital assets, any digital asset. Ownership transfers for assets could happen inside a wallet. Typically, wallets have a hot and a cold portion to it. Hot is where all the transactions happen. So all of these transactions that happen, where ownership transfers happen, assets transfer happen, could all happen inside an environment where nobody gets to see who owns what and how much. And then another big example use case that we're seeing is the signature validator node. Here, if you have a transaction that's about to happen, and you want to make sure it's a transaction that's protected by consensus, signature validation happens. And a very popular algorithm we're starting to see is multiple key shards, where a key gets broken into multiple shards, and then each shard is validated separately, and then they all get put together in a consensus node. This is what it looks like. Now, you can think about each of these shards getting validated inside an enclave, and then eventually a consensus shapes up. That's another blockchain example. But now, don't restrict what I showed you here from a key shard perspective to anchor on what this consensus look like. It could be any other smart contract, any other consensus that could happen potentially in a blockchain where you want to protect the data inside a trusted execution environment like Nitro Enclaves. JD touched a little bit on advertising technology. Here's a very, very good example of that. We recently released a blog on this as well. We worked with the trade desk on that. Is the tokenization for ad tech. Cookies are starting to go away, and now there's a higher emphasis on privacy as well to protect your personally identifiable information. Now, without cookies, how are you going to do that? You need an environment. You need an isolated environment to protect customer privacy, customer data privacy. And you want to be able to make sure, from business perspective, that all of the ads and everything that's getting published is still seamless. So enter tokenization, right? Where the personal information can be brought inside an enclave, tokenized, using UID2, which is just an example I'm using here. Could be anything else, where the data could be tokenized and now used to publish ads, now used to make other inferences based on usage patterns that they've been able to track with cookies in the past. Now those cookies could be replaced by these tokens and still function like they did, like the cookies did. Enclaves actually provide an environment where there's no persistent storage of any of this encryption keys, any of these identifiers. So once it comes in, gets processed, goes out, there's just no more storage. It doesn't persist anywhere else. That's the advantage of using something like Enclaves for an application such as tokenization for ad tech. And then lastly, I want to leave you with one of the most powerful use cases that we are starting to see, which is multi-party collaboration. So we talked about the machine learning model where one person could bring the model, another person brings data. But what if two different parties have data, where they could both bring in data to make meaningful inferences with two separate data sets, but do not have to reveal each other's data to the other party. Let's take an example. Let's just take me. Maybe there are 2 social media companies, perhaps, that have data about me. Both know something about me and could probably make another inference based on what each other know about me, but don't want to share the data with each other. They could drop their encrypted data sets inside an enclave, run a pre-validated, agreed-upon application that could process this sensitive data, and receive the outputs independently to each other without ever having to reveal their original data sets to each other. But they've both learned something new about me, perhaps, in the process. That is just one use case. Another big use case that we're starting to see come out of this, trade reconciliation. Maybe 2 different governments have data on trade. They don't want to share with each other, but they want to reconcile the trade that's happened across borders. So cross-border collaboration, much, much larger scale than what I just talked to you about, personal data. All of those are use cases that are starting to emerge. There's a lot more. I'm just giving you some examples to think about when I talk about multi-party collaboration. I want to close this session out by touching on the last topic that we talked about when we introduced confidential compute capabilities, which is Nitro TPM. We launched Nitro TPM earlier this year. TPM stands for Trusted Platform Module. Nitro TPM is a security device that lets you gather and attest system state, generate and store cryptographic data, and prove platform identity. We did not have this capability prior, where EC2 instances could attest for themselves. But with the launch of Nitro TPM, EC2 instances now have similar capabilities that we talked about when we introduced Nitro Enclaves to you. Nitro TPM is TPM 2.0 compatible. What does that mean for you? If you have workloads on-prem today that rely on TPM 2.0 capabilities, you could now much more easily migrate that into the cloud with Nitro TPM because it conforms to the TPM 2.0 specification. And lastly, there are some new use cases that are being enabled on the cloud because of the introduction of Nitro TPM. Attestation is one of them. Microsoft BitLocker is another one. Linux Unified Key Setup, LUKS, is another use case. We do have all of the technical documentation on our website, and I encourage you to go take a look at it. If you want to learn more about Nitro TPM, feel free to talk to JD and me after this session, and we'll be more than happy to talk to you. We also want to hear from you about some of the custom use cases that you could probably be thinking about as you look into Nitro TPM. I want to close this session out by leaving you with 2 key resources, in addition to the white paper that JD talked to you about earlier. Number 1 is to learn more about enclaves. Just go.aws/enclaves. And number 2, we have a self-help, self-paced workshop for you that walks you through how to spin up an enclave, how to work with it, how to drop your application in there, how do you do cryptographic attestation that we talked about. You can do all of that on your own. The workshop is online, and anybody can go and use it. Please take that link. And if you want to talk more about the workshop or anything about enclaves, confidential compute, we are going to hang out outside, and we'll be happy to talk to you and take questions. With that, I will close out, and thank you for sitting, listening to us talk about confidential compute here today.